I'm going to go over a situation you're going to encounter in your thought primer homework, and it requires a particular approach that I'm going to illustrate for you here. So here's our argument. P horseshoe G, therefore P triple bar G. We've got a conditional statement as our premise and a biconditional statement as our conclusion. So we're going to test this argument for validity with an indirect truth table by writing the argument out on a single line, separating our one premise from the conclusion with double slashes, and then assuming the premise statement is true and the conclusion statement is false. And then what we're going to do is we're going to look for what would be logically necessary for the other component parts of the argument given our starting assumptions. So when we look at our premise statement, P horseshoe G, we want to know if we assume the horseshoe is true, is there anything logically necessary about P or G? And the answer is no. Because when we look at our conditional statement truth table, we see that on lines 1, line 3, and line 4, the horseshoe is true, and they all have different true-false combinations for the left and right side of the horseshoe. So there's nothing we can deduce with 100% certainty about P horseshoe G when we assume that the statement is true. So maybe we'll look at the conclusion statement, P triple bar G, which we're assuming is false. Is there anything that would be logically necessary about P or G given our assumption that the triple bar is false? And the answer again is no, because we see on lines 2 and 3 of our biconditional truth table, the biconditional is false, but the combinations of truth values are different. On line 2, the left side of the triple bar is true and the right side is false, and on line 3, the left side of the triple bar is false and the right side is true. So we're stuck. What do we do? If you said create multiple lines, you're really on top of things. Yeah, we're going to have to create multiple lines, okay? We're going to have to create enough lines to account for all of the possible combinations of truth values that allow either this horseshoe to be true or this triple bar to be false. I always go for the fewest amount of lines possible. That leaves me with the triple bar because there's only two ways for this triple bar to be false. So I'm going to create two lines for this truth table, and on one line I'm going to assume that the left side of the triple bar is true and the right side is false, and on the second line I'm going to assume that the left side is false and the right side is true. Okay, now what I'm going to do is I'm just going to work one line at a time with these assumptions to see if I can successfully deduce all of the other logically necessary truth values without running into a contradiction. If I can do that on the first line, I'm done, because all I have to do is show that it's possible. And if there's one way that it's possible, that proves the argument is invalid. So I'm going to start with line 1. If I can successfully deduce all the truth values, I'm not even going to bother with line 2. But if I run into a contradiction on line 1, then I'm going to move on to line 2. All right, so on line 1, we're assuming P is true here in the conclusion, so it's got to be true up here in this first premise, and we're assuming that G is false in the conclusion, so G would also have to be false there, and we've run into a contradiction, okay? Now that doesn't prove the argument valid because there's still another possible set of truth values, combination of truth values for our conclusion that we don't know makes it impossible or possible to deduce all the other truth values without contradiction. So we've shown that it's not possible to deduce all the logically necessary truth values without contradiction on the first line, but now we've got to move on to the second line, okay? And on the second line, we're assuming that P is false, so the P has got to be false in the premise, and we're assuming that G is true in the conclusion, so it's got to be true in the first premise. And now look what happened. Now we have line 3 of our conditional statement truth table reflected here in our indirect truth table. We deduced all of the logically necessary truth values without contradiction, and that proves the argument is invalid.